Hello everyone, my name is Dinesh. I'm a threat researcher at K7 Labs. For the past 3 years, I've been working with Windows and Mac related threats. I hope you guys are doing fine in this pandemic time. I'll be discussing about the Lazarus Mac-malware innovation in this presentation. Lazarus, also known as Hidden Cobra, is the advanced persistent threat group which is the most researched APT group in our security community. Anyhow, I'm going to give a short introduction about this group. They are the highly skilled hackers who can infiltrate any network without platform discrepancies. It is allegedly believed to be linked with North Korean government. Lazarus carried out an attack on Sony Pictures where they breached their network and dumped the data, and also demanded Sony Pictures to withdraw their movie The Interview, which is a comedy genre on the assassination of the North Korean leader. And they threatened theater owners to not to release the movie. In the investigation report by FBI, they attributed this attack to the North Korean hackers based on the IP involved and the shared code analysis. One of the notable attack was Operation Troy, carried out by Lazarus, which is a cyber sabotage attack on South Korean financial institution and medias, where there was a Viper malware used to take down the system. The same code of the Viper also seen in the Sony Pictures hack. Bangladesh bank heist also carried out by Lazarus Group, where billions of dollars were stolen from Bangladesh Central Bank. It was a SWIFT-related heist. SWIFT network is used by financial institutions across the world to transfer their money in a safe and secure manner. And this group get into the bank network based on a weak link or carrying out a watering hole campaign. After that, they look for a server running the shift software and deploy the malware and withdraw the money. This was the usual modus operandi of the Lazarus around the year 2015 to 16. After that, they shifted their focus to cryptocurrency exchanges. They steal, they hack into the exchange and steal the cryptocurrency exchanges. The below image is the data provided by Group IB, which shows the successful attack on cryptocurrency agencies in the year 2017 to 18. Out of 13 attacks, 5 of them were attributed to Lazarus Group. That's all for the introduction. Let's see how they carry out their operation and how they target cryptocurrency exchanges. Lazarus' first case was a macOS malware was first discovered by Kaspersky. In the report Apple Jeus, they mentioned this APT group sent a spear phishing email to the employee of the cryptocurrency exchange. The mail will be recommending the user to try out the new trading application. The victim will be infected once he download and install the application uh, from the website hosted by Lazarus Group. Lazarus impersonation level was so high that it was not a fake trading application. It was a repackaged version of an open source trading application known as Qt Trader. So this group bundled the malware with the trader. To be noted, the Qt Trader was developed using Qt framework. Qt framework is a cross-platform development framework which is based on the idea like one code base and can be compiled to many different platforms. To be noted, the Lazarus also developed their malware in Qt framework, which serves as a gateway to multiple platform threads. The website had a valid SSL certificate and the package download from the website also signed using a digital valid certificate. This is probably to avoid the gatekeeper, which is a security check provided by Apple. They were projecting themselves as a company. Looking closely at the package, you can see that it runs a script during the installation. Here are the contents of the package. First item is BOM, bill of materials. Second is package info, which is a plist file showing the package information. You can see there is a post install script, which is normal, aiding the normal installation process, but Lazarus has abused this script to execute their malware. And the third item is payload, which is a compressed version of the application. And in the script directory, you can see a post install script is there, which is a shell script which ensure the persistence of the malware and executes the malware. So next part is the installation of the trading software. During the installation, the victim will be prompted for a password. It will make ensure the malware runs with the higher privileges. And the persistent technique is a launch daemon. So here you can see the plist file, which is of a XML type, and the key value is run at load, which ensures the malware runs after the restart. Launch daemons are like the services in Windows, which runs at the background without UI. The common persistent techniques in macOS are launch agent and launch daemons. If you are analyzing a malware in Mac, you can look at these directories for persistent entries. So after the installation, a malware is getting dropped, which is of type loader. So its main purpose is to load this stage 2 payload from the CNC. As I said before, it was developed using Qt framework. You can look at the load commands, which is similar to import in PE file, and it makes the file not a standalone. It requires a dependencies. It before executing the stage 2 payload, it collects the information of the host processes and build version, kernel version. All these informations are gathered and posted to CNC. While analyzing this loader malware, I found how they gathered the list of process in a peculiar way, where they call a systtl function with the appropriate parameters that will return a data snapshot which is stored in a buffer. Here is the X view of the buffer. So they manually parse a buffer to obtain the process list. I searched for this technique. I found nowhere the documentation about this technique. Uh, the first process is at the offset F3. You can see the process name is debug server, and the subsequent process are at the offset 288. So tab space is appended between the process name, and this loops around until all the process names are obtained. So after getting the data from CNC, the loader posts to the sorry. After getting the data from the host, loader posted to CNC. If the response is 200, it means okay, it can go for the stage 2 decryption. The response block from the CNC is base64 decoded and then RC4 decrypted using a hard-coded keys. After that, the decrypted payload is returned to a disk using QIO device write API, and executable permission is set using QFileSetPermission API. And you can see the parameters of 4.1 is passed. According to Qt documentation, it means the file is executable by any user. Unfortunately, stage 2 payload was not able to received, and at the time the CNC was down. And this was for the Mac environment. In a case of the Windows, fault shield backdoor was dropped, which is the eminent tool of the Lazarus group. And this attack was attributed to the Lazarus based on the shared infrastructure and the reusage of encryption keys in the fault shield backdoor. After Operation Apple Jesus, we observed Korean users were targeted using malicious document. The malicious document, you can see the image of it, which is based on the byte on business plan evaluation. Here is the another malicious document. It is interesting because it was probably used to target a cryptocurrency exchange. Another bait on business plan evaluation of virtual cryptocurrency exchanges. This malicious document contains macro embedded in it, which delivers the payload based on the operating system. Here is the macro code snippet. And if it is a Mac environment, the payload is downloaded from the CNC and executed using popen API. If it is a Windows, a PowerShell script will be executed. I analyzed the sample in a Mac environment where a remote access Trojan was dropped from the malicious document. First, it established a session with CNC using curl APIs. You can see that. After that, the response from the CNC goes to SH case and the corresponding function is executed. Below image is the function of a reply other shell command, which provides a remote access to the attacker. It was a simple remote access Trojan without a lot of functionalities and analyze both the Windows and the PowerShell script. Both resembled the same function. You can see that reply try information was both present in the Windows RAT and the PowerShell script executed in Windows. So I suspect there was a framework behind it, and I will be highlighting this framework point on the later slides. After Operation Apple Jesus, there were many trading applications in the wild, which are mostly similar to the Apple Jesus, but JMT Trader caught the eyes of many researchers. It was different because it dropped a backdoor instead of a loaded component. And far more interestingly, it was hosted on GitHub. You can see the download versions are available for Windows and Mac. The JMT Trader dropped in a backdoor, which is of a lightweight component and it is a portable, and it had a basic functionality like file operations and remote access. And it was developed using Objective-C. A previous loader and backdoor was developed using Qt framework, but this time they switched to native Objective-C. You can see a disassembled view of the proc command function, which executes the command from CNC using a popen function. In October 2019, again, Korean users were targeted using trojanized application, where the application was delivered through Telegram Messenger. This was evident based on the forensics report, where the application was collected from the download folders of the Telegram messengers. They used a bait of Korean girls' pictures. So the application, when executed, shows an album of the Korean girls, but at the background there will be a malware dropped and being executed. This is the album.app delivered by Telegram Messenger, which mimics like a Flash player component, and the main executable is Flash player. Let's look into what are the functionalities of the Flash player. Here are the both decompiled view and the hex view. You can see that there is a appended Mach-O binary within that file. So, which is an actual backdoor. The first it copies and write to the disk, and then there will be a hidden file same as .flash player, which triggers the album movies.swf file. So when executed, the victim will be shown a pictures album, but there will be a malware running at the background. This is the last segment of the presentation, the ghost loader. On December 3rd, 2019, I tweeted about the Lazarus Mac-malware, which had the capability to execute a payload from memory, thus achieving a fileless technique. But during my research, it was not the first There were adware and Tola Backdoor was using it. Anyhow, this tweet caught the attention of many researchers. The initial attack vector was same as the previous case. There will be a trading software. While analysis, I found a website serving the cryptocurrency trader. On looking at the domain registration information, I see that the website was valid for only 1 year, which raised my suspicion, and I downloaded the package and started to analysis. The trading application I downloaded, during installation, it executed a post-install script. You can see it is a shell script. It first copies the vip.unioncrypto.plist file into launch daemon directory for persistent, and then copies the hidden file, which is a malware, to a library folder and changes the permission and executes it. So let's look into the functionality of the loader. First, it collects the serial number of the host using IO platform device expert. On the right hand side is the GitHub code I found on the internet, which is same as the malware. So exact dicto was used, and I think the Lazarus group is probably using the code from the GitHub. And then they gather the system information from the system version.plist file, and on the right hand side is the contents of the system version.plist file, where the loader binary gathers the information of product version and product build version, etc. After getting all the data, it pushes to CNC. And the Lazarus group is very cautious in deploying the stage 2 payload, and they don't want their payload in the hands of researchers. And for example, this is a decompiled view of the loader binary, where the time of the host mission is obtained, which is concatenated with the hard-coded value 12GW, etc. And then the concatenated text is taken a hash. So this hash is the value for the key auth signature, and the time is a value for the key auth timestamp. This key value pair data are posted to CNC. At the most probably at the malware operator end, these values are used to recreate the scenario and verify the hash. After posting the data to CNC, and the response is 200, and then the loader can go for the stage 2 decryption. The response block from the CNC goes to base64 decoding and then AES decryption. The key for the AES decryption is the hash of the serial number of the host. So you can see that the collected informations are used at the malware operator end for delivering the stage 2 payload. After that, there was a function called load from memory, which is the actual technique to execute the payload in memory. If not, the decrypted payload will be returned to the disk using popen and fopen and fwrite. After that, they will be executed using a system called API. Let's look into the load from memory function. There are many calls going around. mmap is a system call which allocates the address space, allocates some memory in the virtual address space. After that, the decrypted payload is copied into that address buffer using memcopy. The final call is a function call which is memory exe2. So memory exe2 is a it's a function where the fileless technique is employed. You can see there is two APIs. This fileless technique is based on the memory-based bundle by Apple, which source code was released in 2005. NS create object file from memory, creates an object file from the mmap buffer, and then link the module into the loader file. So Then there should be execution of the loaded file. So there will be find Mach-O function which manually pass the entry point of the entry point of the loaded memory and then execute it. So there will be a manual search for LC main, which is stands for the load commands of the main entry point. After that, the execution jumps to it, thus achieving in-memory execution. For achieving the in-memory execution, the loaded file should be of a bundle type. Okay, the strings reveals the various source files and the environment build. You can see the main.o is a main function and core.o is a remote payload which we are unable to fetch because the CNC was down, and much of the object files are self-explanatory. The username was Mac Mini, so strings revealing much information. We can use a VM map tool to see the mapped file of the process, and also Apple gives a endpoint security framework where we can monitor the mapped file events. So easily you can create a query of the listed map. So you can easily create a query and from the Mac endpoint security, and we can monitor the mapped files. The final part is Dacls rat. NetLab 360 discovered Linux and Windows version in 2009 of the Dacls rat. Dacls rat was attributed to Lazarus group, and the Mac version was found around the year 2020 by Malwarebytes. It was mimicking as a two-factor authentication app known as Tinka OTP. The two-factor authentication app was used by Chinese, and which is a repackaged version of the original open source two-factor authentication app known as Minna OTP. So let's see how the installation logic of the bundled file. The main executable in the function application date finish launching delegate is like a entry code where there will be a bash script executed using NSTask API, which will ensure the malware is copied to the library folder and executed. So the actual malware which is a Dacls rat, resides in the resource directory of the package, which mimics like a nib. A nib stands for Next Interface Builder. So here are the functionalities of the rat. The rat has plugins, which is a full immersive backdoor. Plugin CMD gives a remote shell access and file operations like read, write, delete. And in a plugin process, there is a way to launch a process as a daemon, and also it uses P2P proxies. And one of the interesting function was start worm scan, which scans the subnet for Microtech routers and Bloomberg software, which is very interesting. And also had a log sending plugin. So it is a comprehensive backdoor, and this is also a part of the Lazarus group. And here it shows that there is a framework behind it because it was available to all platform, and all of them share the same functionalities. Mac don't get malwares. This myth is far from the reach. The sophistication of the Mac malwares are increasing. One living example is this Lazarus group, and they are continuously evolving and started to adapt the existing techniques. For example, the in-memory execution is the technique by silence, and they started to adapt that technique. And the APT groups are not after the platform, they are after the target. We can only possibly overcome these advanced adversaries by working together to track their activities and share the intelligence. Thank you.